Hey everyone, welcome to our walkthrough of the SETS exam here. So first thing we're going to start off with is a Venn diagram. Now whenever we see a Venn diagram question, we always want to try and fill in the middle first if we can and work our way out to these intersections between two sets and then out to C, T and D alone. So let's just go through the information here first, I guess. It says 4 people drank all 3, so that's going to be our middle. Sorted. Then I look for information about either of these 3 here. So it says 8 people drank tea and a soft drink, but not coffee. So if I look at the tea and soft drink sets, the people who drank tea and a soft drink, but not coffee, are going to be right here. Because if they were in this section, they'd be in the coffee circle as well. We can see the coffee circle. So tea and a soft drink, but not coffee. That should be 8 people here. Now, another piece of information about the overlap of 2 sets is 9 people drank a soft drink and a coffee. So the overlap or the intersection between coffee and soft drink is here. That says 9 people had a soft drink and a coffee. And we already have 4 of those filled in. So the extra 5 should be right here. 5 people there. The next piece of information I see that mentions multiple sets is 20 people drank at least 2 of the 3. So they drank at least 2. That could mean they had 2, which would be here, here, and here, or 3 right in the very center. So all of these 1, 2, 3, 4 sets, they should add up to 20 people. At the moment we have 4 plus 5 is 9, plus 8 is 17. So we're missing an extra 3 to bring it up to 20 people who had at least 2 different drinks. Now we can work our way out further to people who only had tea, only coffee, or only a soft drink. So something handy I see is 41 people drank tea. So that means all of this tea circle here should add up to 41 people. At the moment I have 3 plus 4, which is 7, plus 8, which is going to give me 15 people. So if I take 15 away from 41, that gives me 26 people there in the tea set alone. So those people only had tea, and that brings me up to a 41 total in the tea circle. Okay, now I've used up a lot of this information already, so I'm really looking for the things I haven't used. If it was helpful, I could cross it off as I went. I want it all to be visible for you though. So next thing I'm going to look at is, I suppose 24 people have not drunk any of the 3. I can add that outside here. That's pretty straightforward. They haven't had anything to drink. 51 people drank tea or coffee but not a soft drink. So the people who had tea or coffee but not a soft drink, that would be here, here, and here. So those 3, 1, 2, 3 sets here, the people who had tea and or coffee but not a soft drink, is going to add up to a total of 51. So right now we have 29. If I take 29 away from 51, let's see what's left. That's 22 people. So I'm going to zoom in, put 22 here, and that's my Venn diagram done. Oh, no, it's not. I'm still missing this section here. Now, if I read through all this information, it doesn't actually give me anything new, but often up the very top, they'll have some information right here about the total number of people. So it says there should be 100 people in total. So I'm going to add up what I have. And that gives me 92. So that means to get to a total of 100, I must be missing 8 people from here. Okay. Next question goes into a little bit of probability from last year. The probability that a student chosen at random from the group had drank tea or coffee. Now they put or in bold here, and that really symbolizes the fact it's this or this, but not both. So how many people that had tea? That's 26 plus 8 who have only had tea but not coffee, and 22 plus 5 who had coffee but not tea. I'm not counting the people who had both, because it says tea or coffee, and with the or in bold really implies that it's not going to be both. So when I add all those up, 26 plus 8 plus 22 plus 5, that's 61 people and that's going to be out of 100 people total. So 61 over 100 is our probability. For the next part, it says find the probability that a student chosen at random from the group had drank tea and coffee, but not a soft drink. So if we look at that section, tea and coffee is going to be this overlap. And if we ignore the people who have had a soft drink, we're ignoring these ones because they're in set D. So it only leaves us with 3 here, tea and coffee, but not in soft drink. So that's 3 people out of 100. So 3 over 100 is fine. You can put it as a decimal. The question doesn't say to put it as a decimal, so I'm going to leave that as a fraction. Okay, next question wants us to give an example of 2 sets that can't be empty for which the intersection of A and B just equals to A. So that's, I guess, maybe a little bit confusing to get our heads around. I'm going to draw a quick diagram here to help us out. So if I have a set A and a set B, A has to just be the same as the intersection between A and B. So I can have elements in here in set A, and I can have elements out here for set B, but this part here, A less B, that has to be empty because the intersection between A and B has to be a list of all the elements in set A. I can't have anything out here. Otherwise, that would be different from the intersection, whereas A has to be the same as the intersection. So I guess as a kind of an easy example, I'm going to say, well, A is going to have the elements 1 and 2 in it, and B can have the elements 1 and 2 and 3. You'll have to forgive my curly brackets, they're a little bit funny here. So again, 1 and 2 are going to be here in the intersection, and 3 is going to be out here. So we could say that set A is just the intersection of A and B. Next question, give an example of 2 non-empty sets P and Q for which P less Q is the same as P. Okay, so again, a diagram here might be handy. So P less Q is this section here, P less Q. And we want to say that P less Q is the same as P. So basically we shouldn't have anything in the intersection here, because if we do, P less Q is not going to be the same as the whole of P. So we should leave this intersection here blank. And Q can have some stuff in it as well if it wants. So basically there shouldn't be any overlap. Let's have a look at what that looks like. So I could have P has the elements, 3 and 4 in it. Q has the elements 7 and 8 in it. So P has 3 and 4. Q has 7 and 8. And there's nothing in the intersection. So P less Q is the same as P. That's what we're trying to get to. Here's P less Q. It just has 3 and 4. We ignore the intersection. And it's the same as the whole set P. So the full set P isn't missing anything from there. On to question 3. We're going to say if these are always true, sometimes true, or never true. So we really want to go through this quite slowly, and let's have a look. I've drawn a nice Venn diagram here to help us out with P and Q in it. Hopefully that will help things along. So the cardinal number of P union Q looks like this, is equal to the cardinal number of P plus the cardinal number of Q. So that one isn't always going to be true, because what could happen there is if there's something in the intersection, if we add up the cardinal number of P, we'd count it. And if we add up the cardinal number of Q, we'd count it. So something in the intersection will get counted twice on this side. Cardinal number of P plus the cardinal number of Q, we'd be counting the intersection twice. For the cardinal number of P union Q, the intersection would only be getting counted once. So if the intersection was empty, it would be true. If it wasn't, it wouldn't be true. So I'm going to say sometimes true for this. Here it says for question 2, P less Q is equal to P intersection Q. So P less Q is this in red. P intersection Q is this in green. As you can see, that is not true, right? Those are 2 very different sets. The only time that could be true is if this was an empty set and this was an empty set, because neither would have any elements, so they both just be empty. But if there's stuff in here, it's different to what's out here. Now, I'm just checking the question because it does actually say here they have to be non-empty sets. So in that case, this could never be true. Okay, on to question 3. Here it says P intersection Q complement is equal to P complement union Q complement. So P intersection Q complement is going to look like this. Right, it's everything apart from the intersection. All right, P complement union U complement. Let's have a look at that one. So P complement union Q complement. P complement is everything apart from P. So that's going to look like this. U complement is going to be everything apart from U, or Q, everything apart from Q. Sorry, it's Q complement. So the question is, does this look the same as this? And the answer is yes. I just used 2 colors for this one. That's the only way it looks different. So this is exactly the same as this. So that's always true. So for the final question, then it brings in a third set OR, which is also a non-empty set, it says. So the left hand side, P union Q intersection OR. So we're going to shade in the intersection Q intersection OR, and we're going to add on the set P. So Q intersection OR looks like this. Q intersection OR, and we're adding on the set P. All of P, not just the bit, but that's P alone. Okay, so it looks like that. That's our left hand side, P union, the intersection between Q and OR. And then the right hand side is P union Q intersection P union OR. So let's look at P union Q first of all. P union Q is going to be this set here. P and Q joined together into a big mega set. P union OR is going to be P and OR joined into a mega set. P union OR. Okay, and we need to look at the intersection between those 2 sets. Where do they overlap? So this part is in both. This part is in both. This part is in both. This part is in both, and this part is in both. So the overlap is going to look like this. Now we have to ask ourselves, does that look the same as the other side? And yes, it does, right? The overlap actually looks exactly like what we had before. All of P circled with this little intersection here. So that is always going to be true because they look the same all the time. Okay, nearly there now. We're on to question 6. This brings in a bit of algebra into our 3-way Venn diagram, which is something that's very likely to happen on a higher level exam. Again, we want to do our best to really fill in the overlaps first, but we might not be able to do it as easily this time. So do they give us the information about the very center? They do. 8 students of all 3 apps. So I'm going to put 8 students in here for all 3 apps. Now I look for information about the other intersections. Okay, so it says 24 students have Instagram and Snapchat. So Instagram and Snapchat is this section here. There should be 24 students there altogether. We already have 8 of them in, so we're going to fill in further 16. So that brings us up to 24 students who have Instagram and Snapchat. 16 plus 8 gives us 24. It also tells us that 14 students have WhatsApp and Instagram. So 14 have WhatsApp and Instagram. 8 of those are already counted here in the overlap. So we need to add on 6 to bring it up to 14. So that's going pretty well so far. Now, if I look at any other information about the overlap between 2 apps, it says this. X students have WhatsApp and Snapchat, but not Instagram. So let's look at where that is in the Venn diagram. WhatsApp and Snapchat is this here, this overlap, the oval kind of shape, right? So it includes this and this. But it says the people who have WhatsApp and Snapchat, but not Instagram. So if we ignore the part that's in circle I, we're just left with this part out here. So that's the amount of people who have WhatsApp and Snapchat, but not Instagram. And it says it's X, which is some unknown number. All right. That's fine because it does say to fill it in terms of X. So we're allowed to have X's in here. Now I'm going to work my way out to WhatsApp only, Instagram only, and Snapchat only. I'm going to do Instagram first because it doesn't have any X's in there already. It says 40 students have Instagram. So if I start off with 40 and I take away the numbers I already have filled in to set I, I'm going to take away 6, 8, and 16. That leaves me with just 10 people here in set I alone. So 10 people only have Instagram. It says up the top, 36 students have WhatsApp. So if I look at this WhatsApp circle, I have 36 students are supposed to be in here, but I've already got 1, 2, 3 numbers left. So I start off with 36, I take away 6, I take away 8, and I take away X. When I take away 6, I'm left with 30. When I take away 8, I'm left with 22. And taking away X doesn't really work out as easily because I don't know what X is. So I'm just left here with 22, take away X. So I started off with my 36, I took away 6 and 8, which brought it down to 22. And then X, I don't really know what that is to take it away, so it stays as an unknown for now. I'm going to do the same thing for Snapchat only. So 54 students have Snapchat. I've already got some of them filled in here. So I'm going to take 16, 8, and X away from that 54. So when I take away 16 and 8, I'm left with 30. And I still need to take away X, even though I don't know what it is. So I'm going to leave that in terms of X. I've taken away 16 and 8 to bring it down, bring my 54 down to 30. But I still need to take away X. I can't do that until I know what it is. So this Venn diagram now, there's no universal set outside, it's finished. Now, predictably, they want to get me to find the value of X. So they tell me there's 80 students in total in that school in 6th year. So all these groups here should add up to 80. So I'm going to write out an equation where I let all those add to 80. So I've done that here. You can see all of the different terms in the Venn diagram add up and they give me 80. So now what I'm going to do is I'm going to keep the X terms on the left hand side, X terms on the left. I'm going to have my normal terms on the right. If anything moves to the other side of the equals, as a lot of these red terms are going to have to do, they're going to change their sign to become, they're going to become negative as they move over it because these are all positive, the red ones on the left hand side. And here you can see I've got the X terms staying where they are, and the constants or the normal terms are over on the right hand side. So the left hand side simplifies to minus X, the right hand side in my calculator simplifies to minus 12. Can change the sign of both sides and I get X is 12. So that's my answer there. So onto the last page, they just want us to translate between set notation and normal writing. So to save my terrible handwriting appearing on screen, I'm just going to translate the English by speaking it out. So it says 8 is the cardinal number of W intersection I intersection S. They have some examples here, like 24 students of Instagram and Snapchat. So if I think about W intersection I intersection S, it's the students who have all three, right? So 8 is the amount of students who have all three, is what I write here. 8 students have all three apps, or they have Instagram and Snapchat and WhatsApp, whatever way you want to phrase it. 24 students have Instagram and Snapchat. How I would phrase that is I would say, kind of like above, 24 is equal to the cardinal number of, and then Instagram and Snapchat, that's going to be the intersection between Instagram and Snapchat. All right, so that 24 is the amount of people who have both of those apps. Next one. So the next one is 10 is the cardinal number of this set here. All right. So whatever this is, we got to figure it out. We start off with I, we take away W union S. So W union S is a set that has all of W and all of S in it. So they would be the people who have WhatsApp, Snapchat, both of them, one of them, whatever. So if we start off with Instagram, we take away this stuff. We're left with the people who have only Instagram. We're taking away the people who have WhatsApp or Snapchat or both, right? So 10 people have only Instagram is what I'd say. It's the Instagram, take away the other two. The last one, more students have Snapchat than have WhatsApp. So we could say the amount of students who have Snapchat, we could write it as this. Amount of students who have Snapchat, the cardinal number of set S, is bigger than the cardinal number of WhatsApp, the cardinal number of set W. And that is done.